Welcome back to Weather Analysis with Mr. CB. All right, we're going to be talking about METAR data in this video. So, if you remember, I talked a little bit about this in the last video. So, METAR data is data that we're going to get from our ASOS stations. Um, and it stands for Meteorological Terminal Air Report. So, it's going to be very useful for people in aviation, but obviously meteorologists ourselves and people studying weather, it's going to be useful for us too. But it's just going to give us a lot of information about what's going on at that specific station. So the first thing is that when we're looking at a map with these stations, they're going to have a circle that shows where a station is, and it's going to be one of these four colors. And depending on what the color is, shows what category it is, which is very important for people in aviation so they can know what visibility that they have. So the best situation would be if it's green, visual flight rules. That's going to be if the ceiling, meaning where the visibility is going to be greater than 3,000 feet. Uh, and you can see for greater than 5 miles ahead. Then the next category is blue, marginal visual flight rules. Um, then there's instrument flight rules, that's red. And then the worst visibility is going to be low instrument flight rules if it's pink or magenta. Um, so you can see what those different values are here. So you want to know what these different levels are. So you can see this on this map. I took a screenshot of it. It's today. It's kind of cut off right here, but I'm recording this on November 12th, 2025, and this screenshot was taken at 16:17 Z UTC. So if you remember, that's the time in Greenwich, England, and that's what we go by for all this stuff. And it's also, you consider it Zulu time sometimes if you see a Z by it. But you're gonna to know what the time is in your local area, you'll have to subtract by a certain amount of hours, and it also depends on if you're in daylight savings time or not. Currently, we're not. We're November 12th. We just got out of it basically, so that means that uh, for Eastern Standard Time, which is where I am, I'll do -5 hours to know what that is. Which that's going to be 11:17 a.m., which is when I took the screenshot. Oh, well, actually, and what I wanted to show you is that you can see the different colors, and it makes sense. Yeah, we have magenta here, not going to be able to see that well, red, but out here, okay, green. All right, there's some symbols that are associated with our station models that you're going to want to know. All of these, it's it's good to know all of them, but the ones that are in red are the probably most important to know. So I'll start right here. So for rain, and snow, they're basically very similar. They're going to be, I don't know why there's a letter V right here, by the way. I don't know what that is. Um, but they have two, three, or four dots. If it's two dots, that's light rain, three, moderate, four, heavy. Same thing goes for the snow, two asterisks, three asterisks, four asterisks. And there's also a letter association, and for both rain and snow, if there's a minus sign before it, it means light, nothing, moderate. A plus sign is heavy rain and heavy snow. Um, we can see over here, there's some dust and sand associations. So HZ for haze, that can be relatively not really that common, but I guess of these, it might be the most. And it's an infinity sign looking thing. You can have FU for smoke or VA for volcanic ash. That's not applicable anywhere where I am, but um PO Dust Devil. That's not that common, but I did see a Dust Devil one time, so I suppose there would have been a PO at that time when I saw that. Um, BR is very important to know, which means mist. Some I heard somewhere that you can remember that by baby rain, BR. Um, I didn't come up with that. You could also consider that light fog, but for actual fog, FG, fog, sky undiscernible. If you have per fog, PR fog, sky discernible. So there's lots of super specific things. FZ, FG, freezing fog. Now, like some of those might just make sense. You might expect the FZ is freezing, but I don't know. TS is thunderstorm, um, with or without precipitation. In a severe weather situation, SQ or FC, which means squall or funnel cloud tornado, that might be more useful in a situation where we have severe weather. Um, Virga, that might be one that just is spelled out, so that's pretty easy. Um, Another one that's really important is freezing rain, FZ Ra, freezing rain, and the same things apply with a negative and positive sign. And the symbol looks like that. Um, you can have some showers too. There's lots of ones, but those are the main ones that you'd want to know. Also, drizzle is the comma. Okay. No, now the METAR data is going to be given in a format like this that kind of looks like code. And the reason why they do it like this, as you might expect, they want it to be concise. They don't want to just have a whole paragraph like "it is raining," like, they'll have it in very concise um code like this so that it's easy to read quick for the people that are in aviation. But also for us, it's important to know too. Um, the first thing that you're going to see is four letters, and that tells you what station it's coming from. Typically that will begin with a K and then three letters after that indicate the station. So this says KOGB. This stands for Orangeburg, OGB. So typically those three letters will seem like an abbreviation or of where it's from. And so Orangeburg, South Carolina is what this example is. That's pretty easy. The second thing is going to have the date and the time at which this report was. Um, so the basically it's not going to tell you the year or month, because that's excess information that it's expected that you know. So to 12 means it's from the 12th. Now of what month? Well, November, because that's when I got this from and it would be obvious to you. So November 2025 and it's the 12th. The next four digits tell you the time. So 1553 Z, Zulu. So if I want to know what the time is in EST now, you might be in a different time zone watching this. So you like obviously if you're in Central or Mountain or Pacific, subtract more hours than what this says. But for EST, you do -5 hours from November to March, and not exactly the first. That's obviously the daylight time, like the exact day. And then -4 hours if it's from March to November. But right now we're in November to March, so I'll do -5. So 15 -5 is 10. So this is from 10:53 a.m. in Orangeburg, which is in EST. So, and then the Z just means Zulu, which is what the same thing as UTC Greenwich time. The next thing you'll see is auto. That's that just means the station is automatic. It just records this information without human need. And almost always it will say that. There's only rare instances when that wouldn't be the case. The next thing is going to be wind direction and speed. So the first three digits are the direction that it's coming from. Remember, everything dealing with wind is always where it's coming from, not where it's going to, where it's coming from. So this says 270. That means it's coming from the west. So you look at this indicator to know 270, it's coming from the west. The next two digits I see are 10, and that's telling us it's 10 knot speed. Now, sometimes that's all you'll see. This G21, not always is that the case if you don't have wind gusts, because that's what that means. So sometimes it might just say a number and then just KT right away. But in this case, it has G21, so it means it's gusting up to 21 knots. So that's what that means. Next, is visibility. This is in statute miles. So 10 statute miles is the visibility. Sometimes 10 will just be the default. If it's so good, they're not usually going to say more than that sometimes. So uh they'll just say 10 statute miles. So that's good visibility. The next thing is sky cover. In this case, I it's very simple. It's just clear. That's what CLR means. But I put an example down here of what it would be like otherwise. So like in this picture in the background, that's obviously not clear. And this picture in the background is actually taken in Orangeburg County last November in 2024. Not that that matters, but I'm just saying that's what I took that picture from. Um, and obviously if this was from this time, it would not say clear. Um, so more often, instead of it just being clear, like the most simple possibilities would be clear, which it's in octas, so eighths of the sky um covered by clouds. If it's overcast, it'll be OVC, which is 8 out of 8, so it's completely covered. But it will after it will say it will have three digits after, so after the indicator, so that five indicators that we have are CLR for clear, few clouds, SCUT for scattered clouds, broken for broken clouds. I don't BKN. I should just say the letters. OVC for overcast. And after the letters, it will have three numbers. Not for clear though, because if it's clear, there's no clouds anywhere. But the three numbers that are after these four are going to tell you the height at which that is. So here's a more complex example of what you might see. So few clouds at 037. What does that mean? So you have to kind of translate it. So you add basically two zeros after the last digit. So few clouds at 20, or sorry, 3,700 feet. Few clouds again at 8,000 or 8,000 feet. Then broken clouds, which means more cover, at you add two zeros again, 11,000 feet. So that's what it'll be like sometimes. It will tell you layers as it goes up because the celiometer that is going to give us this data, it's able to just go and through the different layers because it's useful, especially for planes. Like if they're going through different layers or going up or down, they'll want to know what's going to change as they go. So few clouds, then broken. So you'd want to know the indicators. So clear is nothing, and then few is 1 to 2 eighths covered. Scattered would be 3 to 4 eighths. Broken 5 to 7, and then overcast completely. So that one's probably a more complex one, not in this example, but all right. The next thing is going to be temperature slash dew point. Not that it's either one. It will have the temperature and then a slash symbol and then the dew point. So the temperature and dew point are given in degrees Celsius. So in this case, it's going to be temperature 14 degrees Celsius. Then dew point M means negative, so -2 degrees Celsius. The next thing is the altimeter reading, which reads our pressure, but the pressure is going to be in inches mercury. That's kind of hard for me to say for some reason. And so the A is the first thing you'll see that you know that's what it's talking about. A. Then the number after that, you put a decimal in the very middle of that number. So it's 30.19 inches of mercury pressure. All right, then after this you see RMK. So that means remarks. So further remarks. So it's this stuff right here is always going to be the order that it is. after this remarks, further remarks are just extra things they're telling you. It's not always in the same order and it's not always the same things shown. So that's where this part of the video is going to get a little bit more abstract. I'm just going to tell you all the different ones that you could see. But yeah, like I said, they're not always shown. Not all of these are always shown because some of them don't even they wouldn't make sense together depending on the conditions. You'll see what I mean. So the first thing that you'll see is, and you can see it in this case, AO2. You'll see AO1 or AO2. AO1 means it's not able to determine what type of precipitation we're getting. AO2, it is. So in this case, if we had precipitation, it would know. Um, then next you see SLP with three numbers. That is sea level pressure. You're going to add a 9 or a 10 at the beginning of this and put a decimal in between the second and third number. Because our pressures, this is in millibars, they're always going to be in the 900s or 10,000s, almost always, unless it's like an extreme hurricane or something. Um, so this would be 1022.2 millibars pressure. So that's kind of a high pressure. Um, the next thing that you see is a letter T followed by 8 numbers. So the first 4 numbers are the exact temperature, and you might be saying, what's the difference between that and this? It's if you see 14 and then 13.9, that's close, and then 2.22. So this is just giving us more precision with the temperature and dew point. So the first 4 numbers, um, the first number right here is going to be a 0 or a 1. If it's a 0, positive number. If it's a 1, it's going to be negative. So this is positive 13.9 degrees Celsius temperature. Positive 13.9. So you put a decimal here. Next, there's a 1 in this 4 set of numbers. That's negative 2.2 degrees Celsius. And that makes sense for what we see here. -2, but it's like, oh, actually, more specifically, negative 2.2. So you separate this series of numbers into, there's just a T and then 4 numbers and 4 numbers. The first 4 numbers are the temperature. The next 4 numbers are a dew point. The very first number of each set tells you if it's negative or positive. And then the next three are the actual temperature, and you put a decimal between the second and third of these 3 numbers and these 3 numbers. Um, the next thing that you could see, so that's all that we have for this uh METAR data for this station at this time. Sometimes there will be more things though, and I'm about to talk about what that is. So that if sometimes you'll see a 1 or a 2, like there's always a space in between these things. And if you saw something that's a 1 or a 2, and here's an example of what you could see, it's going to be 5 digits. If you saw 10034, that's possible. Or 21120, that's two possibilities. That's going to tell us our 6-hour maximum and minimum temperature. And it's given at 6Z, 12Z, 18Z, 0Z. Um, so the number that if you have a series of 5 numbers that starts with a 1, that is the 6-hour maximum temperature. And in this case, it would be 3.4 degrees Celsius. So this 1 just tells us that it's the 6-hour max. The next number tells us the next number is a 1 or 0. And remember, that's negative or positive. 0 means positive. Then these 3 digits, just like with this, you put a decimal between the second and the third of those three. So 034, 3.4 is what it really is. 3.4 degrees Celsius. Next, 21120. That is the 6-hour minimum temperature. So the 2 means that it's the 6-hour minimum. The 1 means that it's a negative number. 120. You put a decimal between the second and third. So it's negative 12 degrees Celsius minimum, which that would be a pretty big difference, but that's just an example. Okay. Next, yeah, sorry for all this stuff, but it's important to know. If you see a 4 and a slash, at the beginning of a series. Because remember, all these have a space in between them. If you saw something that begins with a forward slash, that's telling us snow depth. And if here's an example, if you had forward slash 017, the forward slash tells us that it's snow depth, then 017, it's in exact whole inches of snow, so 17 inches of snow. That's only going to usually be at stations where there's a lot of snow. For places where there's not that much snow, it wouldn't be as useful to have this, so that's not as common. If there's just a 4, no slash at the beginning, that is our 24-hour max and minimum temperature. And apologies that I don't have an example for this, but it would be working the same way as this, where it'd be a 4 and then four numbers after. So let me just write an example in that case. Oh, so 24-hour maximum or minimum temperature. So we could have something like this. This tells us that it's the 24-hour max um, or minimum. And then that's that means that it's positive, and this means that it's 1.2 degrees Celsius. So that's how you could see that. Okay, sorry. That was actually not right. Okay. Sorry about that. So it's actually going to be, I was thinking like, why would it be max or min? I'm sorry. So this isn't something that's always shown, but I'm going to say it because it could be. So it would actually be something like this. This would be more like what it is. So it's actually going to be something with 4 followed by 8 digits. You separate it like that. This is the max and this is the minimum. Okay. And same thing. Okay, this is positive 1.2 degrees Celsius. Negative 0.1 degrees Celsius would be the 24-hour minimum. That's actually what that would be. So sorry about that. All right. Now, if you see a 5 at the beginning, that is pressure tendency uh cha change that it has over the last hour in tenths of millibars. So it's going to have first a 5. Oh, hang on a second. I was trying to get onto the laser, but it was doing something bad. Okay. 5 means it's pressure change. Okay. Then the 8, or the second digit that it has, it's going to tell us if it's rising, steady, or fallen. Has it risen? Is it steady, or is it fallen? 8, it's in 5 to 8, so it's fallen. By how much? 0.17, that means 1.7 millibars. If you see a 6 at the beginning, that is our 3 to 6 hour precipitation report in hundreds of inches. So for this one, for you to know if it's the 3 hour or 6 hour report, you have to look at the time that it was. So 1553, that is kind of close to 16Z. And it's closest, well, it's closest to 15, it's closest to 16Z, but of these intervals, it's closest to 15Z. So that would be, if it was there, it would be the 3 hour report. Whatever's the closest to one of these. So 1553 is closest to 15 of these. So sorry that some of this is a little bit abstract, but that's just how it is. Um, so it's 6 means that it's the precipitation report. 0012. You put a decimal right here in between the second and third of these four numbers. 0.12 inches of precipitation. 7 at the beginning is going to be hundreds of inches of precipitation in the last 24 hours. It's only reported at 12Z, and it's going to be in the same fashion as this, where it'd be 7 and then four numbers. If you see a P at the beginning, that's the 1 hour precipitation in hundreds of inches. Same way. The next thing would be peak wind. If you see PKWND, peak wind, and here's an example of what you could see. It's going to tell us the degrees it came from, the knots that it was and the time that it was. So in this case, it came from 340 degrees. That is close to 360. So it's almost directly north. So it came from the north-northwest, you might say. It was 28 knots and it happened at 1736 Z. So that's mostly it for METAR data. There are definitely other things that you could see than just this, but those are the main things that you would see. So hopefully that helped you know how to decode it. Thanks for watching.